I'm going to talk about area of triangles. But to start off, let's actually talk about rectangles. There's a nice connection between rectangles and triangles. All right, so area of a rectangle, base times the height. So area equals base times height. Okay. Now let's talk about this relationship between rectangles and triangles. So if I want to cut a rectangle in half, I could chop it down the middle. I could chop it down the middle horizontally. A third option is I could actually chop this diagonally. Let's see if I can get that just right. There we go. Right. Now, notice when I cut it diagonally, I've actually created two triangles in here. And each of these triangles is half of the area. And notice this triangle that I shaded in shares the same base and the same height as that rectangle. This is true for any triangle that fits within a rectangle sharing the same base and height. And we'll get into some uglier looking triangles, but we're going to start here. So the generalization of this is the base times height of that rectangle. That's for the rectangle. If I want to find the area of a triangle, I can use a rectangle that shares the same base and height and just divide it by 2. I'm taking half of it because it takes up half of the space of that rectangle it fits in. Let's look at an example. Let's say I have a triangle, a right triangle, which means it has a 90-degree angle here, or a right angle. Let's say it has a base of 20 feet and a height of 35 feet. Right. So let's use our formula. Area equals base times height divided by 2. My base is 20, my height is 35, and I take half of that. All right, you can punch that out in a calculator or mentally. Let's see, I'm going to do 20 divided by 2 is 10. 10 times 35, 350 square feet. So this is the area of the triangle. Now, on the left screen here, I have a little interactive animation I put together, or relationship between the triangle and the rectangle it fits in. So here I've got it set up with that base of 20, height of 35. And you can see it automatically is calculating the area for the triangle at 350 units. And then the rectangle, 699, there's a little rounding issue here, but it's about 700. So that triangle is half of the area of the rectangle it's fitting in. Now, I said we were going to talk about different triangles. So these are, everything we've talked about so far were right triangles. So that was a right angle here since we were in a rectangle. But this is true even for different triangles, acute triangles, obtuse triangles. And let me show you this animation. I can basically, or this interactive diagram here, I can just move this around to create whatever triangle I want. You can see here's an obtuse triangle, some acute ones, so the acute ones fit inside of this rectangle. But notice even for this obtuse, the dotted line is the height or the altitude of the triangle. And it's set up to always match the height of this rectangle. So right now they're both at 36.1. And then it's locked in to share that same base of 20. Right? And we could change this base. We can just extend it out. Let's go to 40. Let me zoom out a little bit here. And let's extend this to 40. There we go. So this is a base of 40. And yeah, so regardless of what our base is, it's still just always going to be true. These are always, the triangle is always half of the area. So let me lock this into something a little easier to work with. Trying to get to 500. That's not going to go quite there, but you can see 501. If we double that, 1002 for the area of the rectangle. So let's actually look at another specific example. So let's do an obtuse triangle here. Let's say we've got this guy. Let's say we've got a base of 40. Let's do centimeters this time. And let's say we have this about 34 centimeters. And let's say this is not exactly to scale, but let's say that's 16 centimeters. All right, so let's go to our formula. Area of a triangle is base times height, and then divide that by 2. So our base here is 40 centimeters. Actually, I'm not even bother writing the units right now. And then we're going to multiply that by the height, which is 16, and then divided by 2. All right. So calculate that out. What do we got here? 20 times the 16, we get 320. Square centimeters. All right, let's go play with the animation to verify this. What's going on? So we've already got this base set to 40. Now let's set our height to 16. There we go. Zoom in a little bit. We get a little rounding issue going on with this animation. You can see our triangle is 320 units, and then our rectangle area rounds to that 640, double it. But yeah, even for a triangle that's not a right triangle.